Hi grade 12s and welcome to this video. So in this video we're going to be covering question 7, which is the financial maths section of the November 2024 grade 12 paper 1 exam. Okay, so we have 7.1 and let's get into this paper. Okay, so 7.1 says Mary's grandparents deposited 5,000 into a savings account on the day that she was born. The account pays interest at a rate of 6.8% per annum, compounded quarterly. And then they say calculate the accumulated amount in this account on Mary's 16th birthday. Okay, so looking at this, money is not being repeatedly deposited. It's one amount that gets deposited. Her grandparents deposit 5,000. So we know that this money is going to grow. So from this, because one amount is being deposited and then it grows, we can see that this is clearly just compound interest growth. That's really all it is, okay? And it's compounded quarterly. So let's just go ahead and put down the info. So I usually like to write the word PAIN, P-A-I-N, okay, for our values. And the principal amount, the amount you start off with, is the 5,000. That's how much gets deposited. And then the accumulated amount, as you can see, that's actually what we're looking for. Calculate the accumulated amount. So that is unknown. And then the interest. The interest is 0.068% per annum compounded quarterly. So you need to make sure that you make it quarterly interest that gets added really. So you're going to divide that by 4, really cutting it into 4 quarters so that it gains interest every quarter. And then lastly, N. Okay, so they said it's when she was born until when she is 16. So it's 16 years in total. But remember that this is compounded quarterly. So it's going to earn interest every quarter. So you need to say the 16 years times the 4 quarters that they are in every year. Each quarter is made of 3 months, but that's not really important here. Okay, so that's all we have to do. Substitute and then we get our answer. So our formula is the compound growth formula, which looks like this. And then we're just substituting. So A is equal to 5,000 and then 1 plus 0.068 over 4 raised to the power of 16 times 4. Let's punch that into the calculator and see how much will be in the account. Okay, and the total amount in the account would be 14,706 points. Round off to 2 decimal places, that will be 56 cents. Okay, so just remember, it's just because it's when she was born, okay? It's not when she turned 1 or anything like that. It's when she was born, which we will see as T0, okay? She's not any years old. The baby is not any years old at this point. But when they turn 1, then 1 year has passed and 1 year's worth of interest is going to be added to that 5,000 Rand. And then 2 years worth all the way to 16 years, which would of course be on her 16th birthday. Okay, so that is it for that question. Moving on to the next question. Okay, we're on 7.2 and 7.2 says, after 4 years, the value of a printer was half of its original value. Now, you know, I like to take notes as I read these questions. So they say that there's a printer, it has a value. So it starts off with something. That would be the P value, how much it starts off with. And then how much it ends off with would be how much it ended up being at the end of the day. So after 4 years, the value of a printer was half the original. So it means if the original was 2x, then the printer ends up being x, half of it. Okay. Then they say determine the rate at which the printer depreciated over this period. So they want us to find the interest. If the depreciation was calculated according to the straight line method. Okay, so we're just using straight line decay, or really just simple decay. That's what we're using here. Okay, so we know this, and they told us that it's after 4 years, so we also know what N is. So pain, we know what N is, and we're just trying to find the interest, but we need to also remember to express it as a rate, so as a percentage. Okay, so let's go. We're going to use straight line decay or simple decay, which is A is equal to P times 1 minus I times N. Okay, so our A value is X is equal to, you can really use any amount. You don't have to use X necessarily. If you like, you can start like, okay, maybe the printer cost 100 Rand and then ended up with 200 Rand, it's still fine. Okay, because it's technically still that same idea. So this is 2x, and then this is 1 minus, and your interest, we don't know what that is, and we know that this is 4. Okay, so we're just trying to make I the subject. What do we have to do first? Okay, we can get rid of the 2x, and it's fine in this case. You're allowed to divide technically by an x because the x represents an amount. It's not 0. The printer does not cost nothing rands. Okay, so 2x on both sides, and therefore what happens here? The x cancels. You have an invisible 1 in front of that x, which gives you 1 over 2. Okay, with the 2 there is equal to, and we have 1 minus I times 4 is 4i. So we clearly just have to make that the subject so that we can get I. So why don't we take it over since it's already negative? So that is 4i now is equal to 1, and take the half over, minus a half. 1 minus a half is just a half, and we have 4i. Then we can get rid of the 4 by dividing both hand sides by 4, and therefore I is equal to a half divided by, that's 1 over 8. But then as a decimal, that is 0.125. Okay, you can use a calculator, but yes, 1 over 8 is 0.125. So that is the interest as a percentage. So we're going to have to tell them the rate, right? So this means that the rate is, multiply that by 100. So times 100, that's going to be 12.5%. Again, you can use a calculator. So the rate is 12.5% per annum on simple decay. Okay, so there. So that is it for 7.2, and we move on to 7.3. Okay, well, in 7.3 and 7.3 says, Tipo was granted a loan of 100,000 on the 1st of March 2022 at an interest rate of 13.5% per annum compounded monthly. Tipo agreed to repay the loan over 5 years in monthly installments of, okay, so they're already given us the monthly installments. They told us the loan amount. They told us the interest. They told us how long it was. So they've given us everything here, but okay. And then they say starting on the 1st of April 2022. And the first question is, calculate the total interest that he will pay over the 5 years. Yeah, this question is something they don't really ask a lot, but it's there in textbooks. You will see how to actually find the answer to these questions. The total interest that the person actually ended up paying. Okay, so let's go ahead and just gather the information that they've given us here. So first of all, Sepo was granted a loan of 100,000. So that is the loan amount that was granted. And this was on the 1st of March, so 2022. So we're going to say 1 March, and I'll say 22, so I'll remember. And of course, this loan goes for a total of 5 years. So if it's from the 1st of March 2022, then the last date we'll have for this loan would be in, so 5 years time, 2027. Okay, so it should end on the 1st of March 2027. So I'm basing this on the amount of payments, because if it's for 5 years, he has to pay 5 years and he's paying monthly installments. So times 12 months, he's going to have to pay 60 payments. It still has to be 60 payments, regardless of the fact that he needs to naturally start 1 month after, because that's how present value formula works. They get a loan and then they start paying the next month or the next quarter, depending on the compounding period that you have. So for him to actually pay the full 60 payments, he has to finish on the 1st of March 2027. And I always like to test this out. The reason I want to test it out now is because, you see, this is a case where they didn't actually ask us to find that X amount. They didn't ask us to find the monthly payments. They already gave us that. So we can actually check whether this is accurate or not. So you can easily do that by using your present value formula. Okay, so I'll put down the present value formula quickly. Okay, so you can see the formula. So we can actually find out whether this is actually, true, just to see. I don't know, I usually play around with the numbers just to understand what's going on and stuff. So what I mean by this is I'm going to put down these that I have here, right? I'm not going to put the present value amount, but I'm going to put down this amount of 2.3, right? And then everything else, And by the years, I'm going to actually put minus 60 because I know that he has to make 60 payments. And I want to see if it actually gives us the total loan amount. Okay, very close enough. Okay, so you see that's almost 100,000. It's obviously because of the roundings. So maybe if we like found, two decimals at least, then it would be 100,000, but it would be like 999 and then it rounds up. So you see that, yeah, they did the calculation already for you here. They didn't tell you to go find it. Okay, so that's good to know. We have that. Now, the first question is really just calculate the total interest that he will pay over the 5 years. Okay, so for us to be able to see that, we're going to have to think about how much Tsepo is actually paying. Like how much is he going to take out of his pocket and actually pay every month? We know that he's paying 2,300. So 2,398 cents every month. But for how long does he pay this for? He pays this for a total of how much months? 60 months, because he pays it for 5 years, but 5 years times 12 months each, okay, each year. So that's going to be, this is how much he pays. And let me actually title it that. So he pays, first of all, this amount. And then we can find out exactly how much this is first. I should just say times 60, honestly. 60. Okay, so he pays exactly 138,058.80 cents. Okay, in total. But then now, how would we find out how much interest he paid? In other words, how much extra did he pay? Well, how much did he borrow? He borrowed 100,000. He ended up paying 138,000. So how much interest did he pay? We're going to have to subtract, find a difference. So say 138,058.80 minus the 100,000, because that's how much he borrowed. That's how much he paid. So that's going to be 38,058.80 cents. And that's the interest. Okay, moving on to the next question. Okay, we are now in 7.3.2, which is the last question for financial maths. And it finally says, Tsepo paid 22,398. Yeah, that looks familiar. Okay, which is his monthly installment and an additional 20,000 on the 1st of March 2024 into the loan account. He continues to pay the original monthly installments thereafter. Okay, how many months earlier will Tsepo repay the loan? Yeah, okay, yeah, so this is 7 marks. There's that question. That last question is always, a bit of a headache. Okay, let's break this down. They said that he paid in total 22,398, and they're saying that this amount is his monthly installment. Okay, installment, it's one payment, right? And an additional 20,000 Rand. Now we can actually break that up and see that it is true. Remember that the installment that he's paying every month is 2,398. If you take the 20,000 extra he decided to pay, to help his loan just finish quicker, and then you take the monthly installment that he paid, you see that it gives you that 22. So 2300.98, sorry, right? You see that if you add that together, it will actually give you the total. Okay, so we can actually just look at this in the timeline and just understand what's going on here quickly, because, we need to find out how many months or how many years or months earlier he's going to finish paying off this loan. So we need the timeline. That's going to be a very important thing here. Okay, let's just look at this story quickly. First, he gets a loan, right? Naturally, you're supposed to start paying the loan 1 month later. But I can't just assume that. We need to actually just check whether they actually accepted that or not. They started by saying that Tsepo was granted a loan of 100,000, and then on the 1st of March, at an interest rate of that, compounded monthly, Tsepo agreed to repay the loan over 5 years in monthly installments of this starting on the 1st of April 2022. Okay, so we see 1st of April 2022, which is true. It's a month later because April, we're going to have March and then April, May. So 1st of April, that's when he starts paying like everybody else. Okay, 1 month later. Now, the thing is, with this question, they're saying that he pays 22,000. We can see where that came from, okay? Which is his monthly installment and the additional this. But he pays this on the 1st of March 2024. This is 2 years later from here, okay? 1st of March 2024. This is where, so he pays his payment, great. He pays that payment, but then he also decides to pay 20K extra. Okay, so that's what happens. He makes his monthly deposit and 20K extra. And then he continues to pay the monthly installments, and then we need to find out how many months earlier is he going to finish this loan because of this extra 20K. The thing about this is we are now assuming that Tepo has paid for all of these other installments. And then they just counted this as a very important point because this is the point where he makes a payment on his installment but adds 20K extra. So how do we find out how much left will he have to pay? Okay. Since this was on the 1st of March 2024, how about we find out how much he owed at this point, right? If we can find out how much he owed, we know how much he owes. We can remove 20,000 from that because he's paid 20,000 extra. Okay. So how much is he going to owe after he has paid this payment? Okay, let's see. How we can find out that is just to see how long this period was. This is a total of 5 years. He decides to add this 20K in the second year. So this is after 2 years. So if this is after 2 years, it means that he had how many years left to pay off this loan? He had 3 years left. So I want to find out how much he owes here. So to find out how much he owes here, we can use the present value formula because the present value formula actually helps you to find out how much you owe. Remember in the beginning where I put down the present value formula and I put down the numbers and I only didn't put an amount for the present value. And then by n, I put negative 60. What I was trying to do there is to find out how much he would have owed if he had 60 months left to pay off the loan, which is 5 years. That's really just trying to find out exactly how much he owes when he borrows the loan. It's really just trying to find out the loan amount. Okay, so that present value formula is important for helping you find out how much the person owes at different times. So what I'm trying to find out now is how much does he owe when he has only 3 years left to pay off the loan. So in the second year. And how we can find that, let me put down the present value formula first. Okay, so here all we'll do is substitute, but then we're leaving present value open because we want to find out how much he's going to owe at a specific period, okay, after a specific period. And then the X amount, we know how much he keeps paying every month. It's 2,398 cents. Then I is still the same. It's still the interest, which is that 13.5%, right? Compounded monthly, of course. So that is 0.135 over 12. And then for the N, that's the most important part. The N, he has, this is how you look at it. Instead of, I know that we are at the second year, but we're not going to put 2 here. You see, this says negative N. The negative N specifically stands for the amount of payments you still have to pay. Okay, that's what the N stands for. So instead of putting 2, we're not going to put 2. We're going to say how much payments do we have left to pay after 2 years. You have how much years of payment? You have 3 years worth of payments. But of course, this is compounded monthly. So N, for N, we're going to specifically say 3 times 12, which is 36 more payments left. Okay, so I'm going to try and find out how much he owes at this point. Okay, let's go ahead and substitute. So present value is what we're trying to find. I'm going to say 2,300.98 cents and then 1 minus 1 plus 0.135 over 12 and then raised to the power of negative 36. Okay, 36 payments left to go. And then over 0.135 over 12. Okay, let's see how much he's going to owe after 2 years. Okay, and when I punch that in, I get exactly, oh, I don't like to round off here, but let's just keep 4 decimals. We can't go wrong there. Okay, so 67804 point, and we'll say 9364. I'm keeping 4 decimals because this is not our final answer. Okay, so we know how much he owes after 2 years. Okay, this is when he decides to sort that 20K. Okay, put that 20K in here. Still have to find out how much earlier is he going to actually finish paying off this loan. So now we know how much he owes here. He owes them 67,000. But what happens at this point? He pays off 20,000. So we're going to remove that because on that day he goes to the bank and he pays them 20,000. So now the new amount he owes is going to be, we're going to say 67804, and then, same thing, then minus the 20,000 since he's paying them on that day, which is just going to be 47,804.9364. Okay, so that's how much he owes them right now. And now to find out how long, we need to first find out how long will it take him to pay off this money that he now owes. This is like a new amount. What we can do is, it's almost as if you're restarting this whole calculation, right? You're remembering that he's still going to pay this amount as the monthly installment, but now we're starting from here, right? And we're saying, how long is he going to have to pay off this loan if he's paying this amount? And this is now the loan amount we're going to use. That's how much he now owes. Okay, so let's see. All we're going to do there is we're trying to find that N. We're still using the present value formula because it's still a loan calculation. So with our present value, our new present value, the loan amount, the money that he owes right now is this 47,804.9364. And then the X amount is still the 2,398 cents, 98. And then the interest, of course, is still the same, but the N is what we're looking for. That's the only difference now. Okay, so let's go ahead and put this in the present value formula and find N. That's what we're trying to do. Okay, so that is 47,804.9364 because I don't want it to round off too much, and 2300.98, and then 1 minus 1 plus. Now that I is still the same thing over 12 raised to the power of negative n. Now I'm not going to multiply that by 12, nothing like that, because I want to find out how much months before I can even try to maybe convert into years. Okay, they say how much months earlier. That's the question. I see that now. Okay, so we actually have to tell them in months. So let's leave that as negative n and don't multiply by 12 because you don't want to convert it to years or anything like that. And then all over the interest that you still have. Okay, yeah, numbers. Okay, so what I'm going to do is I'm just going to find the stuff that I just want to be put together. For example, this one, I don't like the way this looks right now. So I'm going to actually just find out what 1 plus 0.135 over 12 is on the calculator as a fraction, because it's easier like that. And so keep in mind that it's 809 over 800. That's what we have here. Right, that's 809 over 800. And then now we can start working on dividing where we need to. So this is an equation and you're just trying to solve for the exponent of n. What you can do is, well, most people usually just multiply both sides by that. But what I do is I try to divide these two together so I can get them to be a single number. So this divided by this first. And when I do that, I get this number, right, with 5 recurring. But then what you can do is remember to use the number ones. It's still going to be fine. So I'll still write 204,531.555 because that's actually what happens. So let's just leave it as 3 5s. And then we still have this at the end, which nothing happened to. There's the reason I'm holding on to the calculator like that and not really putting anything yet is because I don't want to round off and I don't want to have to remember numbers. So long, what we're just going to do is, here's why I wrote this here. I'm going to just rewrite what we have left. Remember, there's no denominator anymore. It's just this number and everything in the bracket. So that's 1 minus, and now this we know is 809 over 800 raised to the power of negative n. And that's what we're looking for. Okay, so like that, and that's all we have there. And now do you see that in order to get closer to the n, you're going to have to get rid of this number. So to get rid of that number, it's been multiplied, so you must divide both hand sides by that number. So ultimately what we're doing is we're dividing this by this number. Here it would cancel because you're dividing by the same thing. But here you just have to say 478 that over this number. And that's why I kept that on the calculator. But you can use the button ans. Here's how I'll do that. So on your calculator, you can press AC because the answer would be recorded. On mine, I kind of have to press equal to first. And then I can say that 47804.9364. And then I can say divided by uns. And then it's actually going to give me the number that I'm looking for. Okay, so this is what we get so long. So make sure you keep using that uns button. It's going to be very helpful. Okay, so the calculation here would have just been the 47804.9364. And then, of course, we would have just said divided by that number that we had. Okay, like that. And then we would still have everything here, okay, which is just is equal to, and then we have 1 minus 809 over 800 raised to the power of negative n. Okay, so that's what we have there. And now we can, of course, write the answer that we got from dividing these two together, which is 0.2372, and this keeps going. So not rounding off yet. So I have 1.809 over 800 raised to the power of negative n. Okay, so at this point, we're just really trying to, the brackets are gone. I don't know why I'm writing them. So those are gone. And do you see that this is negative? Okay, it has a negative in front of it. Why don't you just make it positive by taking it over? So now it is positive 809 over 800 raised to the power of, that is still a negative n. Taking it over doesn't make it positive because it's an exponent. And then here you still have the 1, and then we're taking that answer over. So minus 0.2372 keeps going. So on your calculator, to get that, you can press AC because that is already recorded. I'll just press equal to first, and then I'll say 1 minus uns, and that's going to give me my number there. Okay, so 1 minus uns is 0.7662, and I'm not rounding again, and we still have 809 over 800. You see here, it's really just the calculation and being careful with that. Okay, and we have that now. And now we can finally solve for the exponent, which is currently a negative n. So negative n is equal to, and we're going to use log. So log, and our base is 809 over 800. And our answer is this here. So here's the thing. We're not going to use this because it's going to round off. We're going to use that button uns again. So you can press AC on your calculator. I press equal to first. Then I'll say log with a base and say 809 over 800. And in place of my bracket, then you're going to say uns. Okay. And look at what it gives you. Negative n is equal to negative 23.79679, right? And of course, you can just multiply both sides by negative 1. And so positive n is equal to 23.7967. Okay, let's talk about this now. The question that we're trying to find, first of all, we found out how much he owed after the 20,000 was paid. And then we were trying to find out how much payments must he make to finish this loan that he now owes. And we got 23 point this amount. Now remember, the payments are of 2,389.98 cents. I don't know why I keep mixing that around. Okay, so this is the payments that he keeps making. So you have to now consider this. The question, right, is how many months, this is the question, how many months earlier will Tsepo repay the loan? If you're thinking about how many months earlier he has to pay off the loan, we need to find out how much months is it going to take him to pay off this amount. We got 23.79 that. If he only pays for 23 months, he's not done, because it means he's made 23 payments of this amount. He still has the 0.796 to go. Now that payment is going to be an amount less than this, but the point is still that the loan is not paid off. So we're going to have to round off to 24. Okay, so N here is going to be 24 payments that he's going to make. I hope you guys understood that part. 24 payments must be made to complete the loan. Okay, not just about paying that amount. 23 payments sure of 2,300 and that, but 24 payments to complete the loan. Okay, so now that we know he has 24 payments and we know when all of this happens, it happened here when he decided to pay 20K extra. So he probably went to the bank, was like, okay, I've been paying you guys and here's my payment for today, but I'm going to pay 20K extra. Can you guys tell me how much payments I need to make to finish this loan? Okay, so how we would look at that is he's paid for this month already. Now he has 24 more months to go. So after this, we're going to have to count 24 months from here. Okay, you can calculate that however you want to. You can like one by one count the months, 24 months, and find out. But from the 1st of March, if we start counting, right, 1, 2, 3, and we count till 24, you're going to end up at the 1st of March 2026, because that's exactly 2 years. So from the 1st of March to the 1st of March 2026. So that's a period of 2 years, meaning he's done paying at this point. So how early does he pay off this loan? You see that between the 1st of March 2026 and 2027, that is just 1 year, which is exactly 12 months. Okay, so there. He's going to pay this loan 12 months earlier. Okay, so that is the final answer. Okay, so that is it for this video. And I actually want to apologize for uploading these slowly. I've not been feeling too well, so I've been trying to just take some time off and not record for too long or edit for too long. But I will do my best to upload it. Everything as soon as possible. So that is it for this video, and I'll see you guys in calculus. Bye.